So hello everyone, hope you are doing good and welcome back to my channel. Today we are discussing the day 8th of the April Daily Code Challenge, and it's question 133, clone a graph, right? See, whenever I say clone, there are two types of copying. Okay, one is the deep copy, one is the soft copy. Soft copy means we'll create a data structure which will be linking to the original data structure, right? If you, for example, if you're doing CBB, if you are making a pointer like that, you press the location of the pointer. If you print the location of the pointer, it will be the same as the original data structure, right? You just created a pointer which is a reference to it, right? But when it comes to deep copy, it's a totally new data structure which has exactly same like data members as they have the original structure, but there's nothing in common. Okay, it's a totally different data structure, a totally different location along the memory. Okay, so please keep these things in mind. I will again repeat: a deep copy means we are creating a totally new data structure. It may be exactly a copy of the original data structure in terms of values, but the location wise, the location and the memory should be totally different, right? So here in this question, they are asking us to make a deep copy of a graph, and here is the structure of the graph. Okay, so each node of the graph will have a integer value, which is its value, right? And it will have a list of nodes. Okay, for like its neighbors. For what will happen in the neighbors array, it will have node objects. Okay, these are not integers, right? These are node objects which are neighbors of the current node which has a value is equal to val. Okay, I will again repeat: the list node which you're seeing is the is data type for the neighbors array. Neighbors array, what it will have, it will not have integers, right? It will have list objects. Okay, it will have list objects which are neighbors of the current node whose value is equal to val. Okay, so that is the all about it. And yeah, and one more the important thing is how to see. Ultimately, we have to return a like similar data structure, right? Exactly same. We have to create again and do return. So whenever you try to create something, you should understand how the constructor works. Okay, so this is how the constructor is working. Uh, I will just increase the font size. So this is how the constructor is working. Whenever you call object, if you pass the first value as the val of the object, right? So that will be allotted to its val. And you are passing, see, if you are passing array, it will be allotted to the neighbors. Okay, neighbors, if the neighbors is not none else, so these are the two values. Either it will be none or it will be a list, right? And the list will have known objects. So I hope the question is clear. See, we are given a data structure like this. We have to deep copy. Deep copy means we have to create exactly another data structure, but it should not be in any way related to the original data structure in terms of memory locations, right? Now coming to the solution of it. So see, I am going to use the hash map concept here. Okay, there are many ways of doing it, but I will use the hash map concept, right? When I already told you that how the constructor is working, that also I told you. Okay, you will just need to create a node object. The first value will be its val, and second value will be either a array or a none value, right? Now coming to the answer part of it, if node is none, then return none. Okay, because if there's nothing to make a data structure, there's like that source data structure itself is like a none, then simply return none. Okay, now comes the important part of it. This is a key value pair. Okay, what are its keys and what is value, I will explain it once I like go through this follow, right? We're doing a DFS. Okay, I'm calling the DFS on node. Node means the given node to us. Node is given to us, right? First node, which is the root, maybe you can call it the root, is given to us, and I'm calling a DFS on it. What will happen if the root is none? Then simply return. Okay, if it is not none, that means it has a data member val, it has a data member neighbors, right? Which are not none. It's not a leaf node, right? So what will happen in the array? The key will be its value, integer value, and I will open a list sorry, the key is the integer. Okay, and its value is a list. Okay, I will print and show you as well. So for a, what is the thing? Key is integer value, which may be a node of the graph, right? And its value is a simply list of neighbors in terms of integers. I'm not capturing their locations currently. I'm only capturing its value, right? You will see that also. So whenever I witness a new node, I will make a entry in my dictionary A in terms of its key, and finally, in terms of its value, it will be a list. Okay. So for now, I will iterate over its neighbors. Okay, and I will append its value. See, I'm not appending its index. Okay, I'm not appending its value, right? See, I'm not appending its location. Location means if I do simply dot append of I, that means you are appending its location. Okay, you're appending its location. We are not doing that. We are just appending its value. I will just print and show you how it looks. But before that, let us see how this function is designed. So for I and its neighbors, if you find a root which has a neighbor, what you will do is in its key, which is the like the root node, just append its neighbor's integer value. Okay, I will again repeat: if you find a neighbor in its integer. See, key is also integer. Its value is also a list of integers. Okay, just forget about this. It's not a list of node as of now. It's a list of simple integers. I will print and show you. If I dot while not in a, that means if the current value which I am discussing is not in a, that means it is not witnessed till now. You just have to DFS out of it. Okay, DFS of IC. We are not doing I dot val here. We're doing full I. I is like a list node. Okay, I dot val is just like integer. If I quickly print and show you what is A? A has key and value pairs, right? Key is like the nodes of it, and value is like the integer neighbors of it. For example, C. For the node I, these are the neighbors, right? So similarly, I in terms of integer, I've just captured them, okay? Because I have to create a new data structure. 2 is a again a key. Its values are 1 and 3, okay, which you are seeing here. Okay, compare its index. This index 1, this index 4, this is index 3, right? Index 3 has these neighbors 2 and 4. So index 3 has these neighbors 2 and 4. Okay, like this it's happening. Finally, we have to make a real data structure. How to do that? That I'm using with like I'm taking help of another hash map, right? What I'm doing is I'm just passing through the keys of it. Okay, I'm just passing through all the keys of it, and finally, whenever I invest a new key, I am making, see, I will be a integer. Key will be integer, right? Key will be integer. Value will be a node object of it, corresponding node object. See, for each integer which you have seen till now, there has to be a node object out of it, right? So this is what I'm doing. See, this part is like capturing the data structure. Okay, this part is like capturing the data structure. This part is imitating the data structure, and we are making new data structure out of it. So these are the two parts of this question. Okay, the first part was capturing the values of the data structure. The second was making a new data structure out of it. Okay, so what we're doing is I'm going through each of the key values. So this is only for like print and see. Now this you will understand. Okay, and BFI means for each node which you visited, its value should be, see, keys should be integer. Okay, and its value should be a node object. Node object. See, this is the constructor which I told you, right? This is the constructor. What I'm passing, I am passing I. Okay, I is like integer value. Okay, because A has keys of integer, and the neighbors will be a empty list as of now. Okay, I'm printing the B value. You can quickly see it's like a, it will print its locations. Okay, you can clearly see one has this one location and node object. Similarly, two has this particular region as a node object. Similarly, three has this node object, right? It will print its locations, its hex values, right? So that is done. Now, see, the node values are created. Now we need to append its neighbors. What we are doing? So we are just iterating over the value key and value pair. See, a dot item means I is its key, j is its value. Okay, whenever you see a dot items, that means I is the key values and j is the values. Okay, of the keys. For k in j, that means we are going into the integer neighbors of it. See, what is the value of see, whenever we talk of hash map A, what are the values? It's a list of neighbors in that int, right? So whenever I'm, see, now I'm just iterating over it. For k in j, that means for the integer neighbors of the node I, what we're doing is b of either neighbors. Okay, b of I is already created. Now it's a node object. I'm calling its neighbors. Okay, in that neighbors, I'm just appending the node of b of k, means node of k, right? What is b of k? B of k is the just a node. It will reference to a node, right? See, just remember these part. That's why I wrote it here. Whenever you give integer for see, whenever you call b of I, if I is an integer, then it will return its node value. Okay. So what I'm doing is when b of I, I'm just accessing its node. See, this is we are calling the node. It's accessing its neighbor's data member, and finally in that I'm appending. Okay, I'm appending the node of which is represents neighboring neighbors, right? Which represents neighbor. So here what we had here, just we had integer variable. Like, see the difference here. Here we had integers, right? Here we are having the data members as node objects. Okay, here we are finally the node objects which we are having the neighbors. We are appending its corresponding node objects. Okay, and finally we are returning b of node.val. Okay, so node is the actual node given to us. We are returning its value. We are returning its value means it will represent the actual node. Okay, it will represent the actual node of it. Okay, whenever you pass a integer to b hash map, it return the location of its object, which is node object, right? So this type of questions are a bit difficult to understand if you are not very confident about Python language. But I will just see that, see, as I told you, if you have to answer this question, see, these are two parts. First part is capturing the, see, here we're not making any object out of it, right? We're just capturing a node and its neighbors in terms of integers. Now we have to make a like a graph out of it, right? So for that, what we're doing, we're capturing. See, we there should be some control. Whenever I click I should get its location, right? Its node's location. This is what is done with B hash map, right? Whenever I pass I to it, it will return me its node value, right? So what do I have to do? When I know that, I will append in its neighbor all the neighbor's value which is in terms of nodes. Okay, because its neighbor, which is array of nodes, right? It's a list of nodes. It should not be a list of integers. So we have to append its corresponding location of its neighbor. Okay, this is what we are doing here. So yeah, friend, that was all for today. If you like my video, please like and subscribe to my channel. Okay, and yeah, thanks for today.